Now we have a real world problem to find the initial velocity required to reach a certain height. We have the problem here. It has been reported that former basketball star Michael Jordan has a vertical leap of 135 centimeters. Ignoring air resistance, what is the initial velocity required to jump this high? Now over here, we have been told the height over here, the maximum height is 135. What is the velocity required to jump this high? Just like the previous problems, we will write the given. The initial velocity is not mentioned, so it's 0. H of 0 is 0. But what is this? H at time maximum. This maximum time we have 1.35. That's fine. What about the next thing? What is needed to be solved? That is the initial velocity for this particular jump. Okay, it is not initial velocity at any time. It is at this particular jump. Okay, we will come to that in a while. But how do we find velocity in general? Integrate acceleration. We have done this many times now. You can pause the video and start continuing for the next few steps at least. Now over here, when you integrate this 9 minus 9.8 meter per second square, we will get minus 9.8 t plus c. Okay, this is the velocity at any time t. Now, how do I find the initial velocity? V naught. That is at time 0, isn't it? H dash of 0. So, H dash of 0 is basically the initial velocity. At initial velocity, what is the time? It's 0. So now, H dash of 0 means initial velocity. What is the t? 0. So what is remaining? C. So this is the initial velocity, the constant of acceleration c value. So now over here, this h dash of t, you can write it as negative 9.8 t plus c. Why? Because that is the initial velocity you need to add to it. This much is basic. We have done this previously. Same thing is repeated. Now we need to find the height. We have done this as well. You need to integrate the velocity over here. So when you integrate the velocity, you get the position or the height. Over here, what is the integration of this? It will be 9.8 t square by 2. That is negative 4.9 t square. The minus sign, that's why it's minus. Over here, t square plus initial velocity f naught times t plus c. Okay, now why do we do this? Now what we do is we will find the see over here, we know what initial height, so we can find the c value, but this is not that useful, but we have to do it. I'll tell you why. C is 0, it's given. You should substitute over, you'll get 0. Now you'll get height. Okay, but this is not the height we want. It is h of t. It is not exactly what we want. We want initial velocity for this particular height. Now this doesn't make sense. This is not the initial velocity we want. We want at t max, at this particular 135 centimeter. Okay, I forgot to tell you one important thing. We generally convert it to meters. Why? Because we have acceleration in meters, so just convert this 135 to meters. It is 1.35 meters. Okay, this is just two zeros over here, so that's how. um, it's centimeter, it's 10 to the power minus 2. You have to take two decimals that side, it'll be 1.35 meters. Now over here, after this, till now it has seemed like the previous problems. I hope you recognize this. Till now it has seemed like the previous problems. Now what do we do? Here now we'll find the maximum altitude. How do we find the maximum altitude? In the last problem we learned maximum altitude, the height is maximum when the velocity is 0. It's increasing, it reaches 0 and then it decreases. So at that particular point, change in the direction happens. H dash will be 0. I told you in the last problem, it does not change, it's always standard. So that is always standard. Now over here, we can see that at h naught is equal to 0, whatever happens is the maximum height. This height is maximum. So h, we have the velocity over here, right? Velocity equation. h dash of 0, put it as 0, and solve what is remaining. You can get the time maximum. See, this basically h dash of 0 means it's at the maximum altitude, maximum height, isn't it? So whatever the time is there, that is the maximum time. So what we are doing over here is take this to the other side, it becomes plus 9.8, and t divided you have 9 point, say it's like this, 9.8 t equals v naught. So all we do is we will just divide both the sides by 9.8. You will get T max is equal to V naught divided by 9.8. Why do we write T max? Basically, that is the maximum time. That is the time, sorry, it's not the maximum time. It is the time where maximum altitude occurs. That is why it's T max. Now, the height at about this time is always maximum altitude. Now, over here, this was the maximum altitude, isn't it? Look over here, we have this. T max is what? T max is V naught by 9.8. So instead of h of T max, we'll write h of V naught by 9.8 because this was the maximum height it was jumped. So this is a maximum altitude and that will occur at this particular time. T max, that is V naught by 9.8. Instead of T, we are substituting this. And now we will solve. In the initial velocity, see over here, the initial velocity, sorry, height over here, h dash. Here we got this as 0, so this is the equation. Here what you do is that initial velocity can be solved now. I'll tell you how. All you need to do is instead of t, put this value. Okay? Instead of t, you have to put this value. So you can see the time will be substituted into v naught. So now what is the unknown variable? It is v naught, so we can easily solve it. H of v naught divided by 9.8 is 1.35. You can write over here 1.35. Now t square is v naught by 9.8 square. Now what is negative 4.9 divided by 9.8 square? That is negative 5 by 98. You can do this in calculator. Let us just do it. If you're getting confused, see, just remember this negative 4.9 is outside, but the bracket, sorry, the it is like this. V naught, let's leave it. So it's 1 divided by 9.8 and square. Okay, so that is the answer. Or in simple understanding, you can just write minus 4.9 divided by 9.8 square. That is the answer, negative 5 by 98. Now over here, what is happening? V naught times V naught is V naught square. Look over here, the numerator also V naught becomes square and the numbers you can solve it. Now what is unknown? Only V naught. So add these both. Add negative 5 by 98 plus 1 by 9.8. So 5 by 98 is the answer. So over here you can get 5 by 98 V naught square. Now take this to the other side, 98 to the other side, multiply by 1.5 and divide by 5. The answer is 26.46. What do we do? 1.35 numerator, denominator comes to the numerator over here. So it's multiply by 98 divided by 5. The answer is 26.46. Now this is not the answer. Square root of 26.46 is the answer. That is 5.14 meter per second. So this was the velocity required for the vertical jump by Michael Jordan to reach the height of this. So the jump was at this velocity and then only you can get the maximum altitude of 135 centimeters.